What is the backpropagation algorithm? I assume you know the gradient descent algorithm. Please remember this formula because the main idea starts from here. I explained this formula in another video and you can see the card at the top of the screen. For example, this is a neural network. This neural network has several inputs, several hidden layers, and several outputs. Let's simplify the network. Each of the white dots is an artificial neuron, and an artificial neuron becomes a function that has two inputs. These are mappings of points to functions with two inputs. We know that every function has an output, so we label them. Let's assume this is the correct answer we expect. And this is the response we received from the network. Okay, this arrow represents the distance to the correct answer, which is the same as C. The output of the first function becomes the input of the second, and the output of the second becomes the input of the third, and so on until the end. Let us transform R into the output of the final function. And we define the input x1. To compute the first output, the weight of the first neuron is multiplied by x1 and calculations continue up to the final function. Now the question is, how do we adjust the weights that the error reaches its minimum possible value? We can start with derivatives and the ratio of chains. Let's begin with the weight of the first neuron. Remember, at the beginning of the video, I told you to memorize this formula. Now the question is, by how much should we change weight 1? The ratio of chains appears directly in this formula, so we can use it to update the weights. Isn't that interesting? Let's substitute it into the formula. To compute the derivative of the error with respect to weight 1, we need to move from the error back toward the weight and take the derivative. For this, in neural networks, we use the chain rule. Alright, let's calculate the derivatives. Alright, let's calculate the derivatives. In the next video, we will talk about the alpha coefficient.